do you say? What's the question of the day? I'm Professor Q. So glad to be with you. So, what is the question of the day? Has to do with a solid, a liquid, and a gas. Is there a material or substance that can be both a solid and a liquid? Ooh, that's good thinking. Fun trivia. Well, what I'd like for us to discuss today is a little bit more also about how we can have these solids, different types of solids, mixed together. And ultimately, that's called a mixture. And when we can also take liquids and put different liquids together, but that even more so is called a solution. So let's have a little bit of fun and have some inquiring discoveries. Inquiring minds want to know solid, liquid, gas. Oh no! Well, let's talk about mixtures and solutions just for a moment, shall we? Well, mixtures have to do a lot with both solids, a lot like trail mix that we might know about. But the question is, can solutions be a mixture too? Absolutely. So let's discuss a little bit about mixing solutions. We have 3 cups of water. Now, one thing we need to identify when we're looking at solids, liquids, and gases are physical properties of each. That's very key and unique to them. So what are the physical properties of what we know to be water, H2O? Taking a look, well, water is transparent or clear. It is wet. Does it take the shape of the cup? Does it have an odor? Use your prior knowledge to write those notes down. Next, my question to you is to make a prediction. I have food coloring that is yellow, blue, and green. What do you think will happen when I drop some food coloring into this first cup? Write those notes down right now, please, in your science class notebook. Great. Well, let's find out. Write down your observations. 1, 2, 3, 4. Ooh, what can you observe is happening? That is so neat. Can you see how that the food coloring is starting to disperse throughout? Slowly, but absolutely surely. That kind of reminds me of, can a sense or scent of odor be dispersed throughout the air? Because this is being dispersed throughout the liquid. Of course. Have you ever sprayed some perfume on one side of the room and eventually it would come to the other? Or what about the peeling of an orange or tangerine on one side? Yes, you start to smell that wonderful aroma. Well, let me go ahead and start to stir just momentarily to make some observations. So what can we observe about the color of cup 1 compared to an original water? Of course, right off the bat, you can observe with your eyes that you're seeing that the color has changed. No change there at all. Did the odor change? You need to waft it correctly. Is it still somewhat transparent? To a certain degree. Does it still take the shape of the cup of the liquid? Yes, the liquid does so. Okay. Well then, that's very interesting. Well, the next question is, let's moving on to cup number 2. What would would happen if I had put blue food coloring? Go ahead and make your prediction, please. Fantastic. Let's go ahead and make that right now observation. Oh my goodness. Whoa. Look at the dispersion here compared to that of what it was with the yellow food coloring. That's really pretty, wouldn't you say? Darker, a little bit more concentrated, kind of stringy just a bit. Well, let's go ahead and stir that just a bit. So, in comparisons between cup 1 and cup 2, could we say that the liquid is taking the shape of the cup? Of course. But what about the transparency? Well, because the blue is a little bit darker, it's a little bit more difficult to see through, but yet slightly transparent. Does it have an odor? Not quite with the waft. Well, let me ask you this question. What do you think will happen when we place the green food coloring into the third cup? Go ahead and write your prediction down now, please, in your science class notebook. Oh, you've had some wonderful thoughts. Well, let's make that observation now, shall we? Do you think it's going to disperse like cup 1 and cup 2? More than likely. 1, 2, 3, 4. Wait a minute. This is what do you observe? This is green, correct? But it turned blue. Oh my goodness. Why do you think it did such as that? It's the same liquid. However, this is the green and it turned blue. Oh my. Now, what was the dispersion? Actually, it was a little bit faster for some strange reason. But let me go ahead and stir if I could. Oh, wow. Inquiring minds want to know why that occurred as it did. So this should have been yellow, blue, and green, but instead it's yellow, blue, blue. Hoo, hoo, hoo. What do you think would happen, just for the fun of it, if we would actually take some of cup 3 and put it into cup 1? Make your prediction now. All right, I'm going to use my handy dandy pipette tool, and let's see what transpires into cup 3, which should have been green, and now it's blue. I just don't know why. Any smart people out there can tell me? All right. What is occurring to cup 1? Did you say it's starting to get a little bit darker? Is it turning blue? No. Then what color is it turning? Well, let's see. Maybe a little yellow-green. Wow. What happened? I just don't know. Well, maybe you can go ahead and have that conversation now with your peers and determine what was it in this mixture of solutions that we have that caused this type of reaction to occur. Have fun now having those conversations. And don't forget, good, better, best. Never let it rest till your good gets better and your better gets